was born and raised there, and yeah, I did my bachelor's in computer science in Arunai, and then I moved to Germany over around 15 years, and I did my master's, and I've been, you can create a line or you can create a boundary, and only within that boundary, the robots are operational. In other place, they're not able to work independently, right? So what happens in case of an autonomous mobile robots is these are intelligence machines which are capable of performing the task in the real world by themselves without explicit human control, right? So the cannot do, right? So that is the whole point of AMR. Uh, Today, AMR has reached even every household. For example, from a simple vacuum cleaner, the robot, which is cleaning, the cleaning robot, to much more complex AMRs, which is used in Industry 4.0 and beyond. Okay. Right. Then let's have a look into how the AMR thinks, right? In general, robot works in a think, sense, act as action. The action is sent to the actuators or the motors, etc., so that the robot can do its job. Okay. Yeah. I hope you guys are following, right? I mean, for the sake of simplicity, I'm having the discussion in English, and we can switch to Tamil whenever needed. But yeah, I think எனக்கு ஒன்றும் ப்ராப்ளம் இல்லை, வேணும்னா தமிழ்லையும் பேசலாம். Okay. Going back to the AMR hardware, are you guys still with me? Hello?
Yes, all are here, sir.
Yeah, okay, all right, because
Yes, Balaji, go ahead. All are here.
Yeah, all right, I got a sound that.
Yeah, Balaji, the question and answer session may be partly in Tamil also, so that's
yeah, that is okay. கண்டிப்பா சார், நீங்க கேள்வி தமிழ்ல கேட்கலாம், அது ஒண்ணும் language வேண்டாம், யாருனாலும் தமிழ்ல கேட்கலாம்.
We will instruct accordingly, both bilingual in question and session.
கண்டிப்பா, yeah. ஏன்னா இப்போ ஏஎம்ஆர்ன்றதை என்னால தமிழ்ல கூட என்னால அதை டிரான்ஸ்லேட் பண்ண முடியாது. ஸோ இந்த டிஃபிகல்ட்டினால தான் நான் இங்கிலீஷ்ல பேசுறேன், மற்றபடி தமிழ்ல பேசுறதுக்கு பிரச்சனை இல்லை. மோரோவர் யா, நான் சந்தோஷமா படுறேன், ரொம்ப நாள் கழிச்சு நானே தமிழ் பேசுறேன். ஸோ அதனால ஐம் ஃபைன். By the way, from the hardware standpoint, I just put into 4 broader areas that the robots will be using, right? One is the CPU, like I mentioned, which is basically the brain of the the robot. Then the sensors, and the sensors are basically the input devices where you sense it, right? The sensors can be light sensor, luminosity sensors, sound sensors, where it measures the sound decibels, and temperature sensor, accelerometer to measure the different speed, right? And then you can also have camera for computer vision based things, so that you can do object classification and things like that. And then followed by LiDAR, which is laser based light detection and ranging, right? Which is also used in case of obstacle detection, right? Then followed by the motors and controllers. So the motors and controllers are the one that is like moving parts of the robot itself, and the actuators are the devices that is actually moving the joints of the robots. Okay, so these are, I would say, some of the broader elements that is part of the AMR hardware. Okay. A little bit about the types. So I have put it into 4 major categories, but there are definitely a lot more. But these are basically based on how the type of motion is being employed in the robots, right? So these begins with the rolling robots, which is basically robots with wheels. The wheels can be 4 wheels, 2 wheel, like 2 powered wheels and 2 free rotating wheels, or it can even be 3 wheel, right? So that there is 1 omni wheel and the 2 wheels with a differential acceleration. It can move left and right right? And so on and so forth. The walking robots typically will have a kind of a leg. So what are all the possible movements? Could be lift, step, front, and then lift down. So, and it has to do this in a recursive manner, right? And if it has to come back, then it has to lift up, go back, lift down, and it has to do it in the same paradigm. It has to do this recursively. And there are industrial robots that's used in the production line, and research robots used similar to the ones that's been used in the Mars exploration and things like that. Nowadays, even we know that in Mars they have deployed autonomous drones for the exploration of Mars as well, right? So these are some of the research robots. So how does artificial intelligence play a role in AMR, right? Artificial intelligence by itself, meaning we are letting the machine to think like human, right? Like I mentioned earlier, we are not trying to replace human, but we are improving the neural network capacity so that the sensor inputs are fed into a machine learning model, and with this machine learning model, it is doing learning, right? Similar to how இப்போ நம்ம குழந்தையா இருக்கிறோம், ஒரு குழந்தைக்கு நம்ம மதர் டங் எப்படி சொல்லி தரோம், நம்மளுடைய தாய்மொழி எப்படி சொல்லி தரோம் இல்லைங்களா? அந்த மாதிரி தான். ஸோ ஒரு முறையும் நீங்க சொல்ல 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 அந்த குழந்தை எப்படி கத்துக்கிட்டே இருக்கோ, அதே மாதிரி தான் மெஷினுக்கும் வந்து there will be inputs and there will be model. Using this, you are making a learning, right? This learning can be different types. We call it as reinforced learning, supervised learning, non-supervised learning. So many types are there, right? So you're having this constant learning. You are letting the machines to think and store and behave like you create a scenario like if a human faced with this scenario, how he or she will behave, the robot will behave similarly, right? So that is how you import human intelligence into machine. So what are all the advantages of it? The advantage is you can add features to the existing robot very agilely, meaning you know your robot, it's working in for example, in a production environment that is bringing things from point A to B, right? And now you want to teach the robot in a way that instead of going from A to B, it can also relay the message to the nearby robot to tell that, okay, I'm too far to go to B, but since the other robot is close to the point B, you can take the job instead of me, right? So these kind of features could be deployed very easily, right? And you can achieve a lot of generic solutions by it, and you can the range of applications you can do it is enormous. The field is enormous. The opportunity you can see here is enormous, you know. And of course, it's very easy to modify because, you know, like I mentioned, all these are neural network based AI machine learning, which is easy in deployment in a AMR situation. An example I give here is an autonomous driving car, right? What is an autonomous driving car, right? You guys can ask me, எல்லாரும் கேட்கலாம் என்ன, எங்க நாங்களே கார் ஓட்ட முடியல இந்தியால எல்லாம், அட்டானமஸ் காரை பத்தி பேசுறீங்களே, அதுல என்ன ரெலவன்ஸ் இருக்குன்னு கேட்கலாம், ரைட்? இட்ஸ் a very fair question to ask. பட் நான் உங்க எல்லாருக்கும் ஒண்ணு கேட்கிறேன், நம்மளும் நம்ம ஃபேமிலிலயோ எத்தனை பேர் ஒரு சாலை விபத்துல நேரடியாவோ இல்ல ஒரு நம்மளுடைய உறவினர்களோ இழந்திருக்கோம் இல்லையா? இப்ப நம்ம இந்த கால்ல இருக்கிற 100 பேரையும் somewhere or other we would have been affected, right? So this is the truth, right? In fact, they say that the number of deaths occurring in the road is hugely high proportionate to the other accidents, right? Air accidents or industry accidents whatsoever, right? So that is why autonomous driving is quite relevant, right? You can ask me, நீங்க கேட்கலாம், இன்னிலிருந்தே வந்துருமா அப்படின்ட்டு. இன்னிலிருந்து வராது, பட் நம்ம ஃபியூச்சர்ல வரும். ஃபியூச்சர் எப்படின்னா, இப்போ உங்களுக்கோ எனக்கோ பேர குழந்தைங்கலாம் இருக்கும்போது அவங்களுக்குலாம் வந்து என்னது டிரைவ் பண்ணணுமா அப்படின்னு ஒரு கேள்வி கேட்பாங்க. அந்த டிரைவிங் பண்றணும்ன்ற ஒரு அந்த ஸ்கில்லே வந்து இருக்காது, டிரைவர்ன்ற ஒரு வேலையே இருக்காது. there is nothing called driving a car, right? The car will do its job, right? So there will be car. You will still use car as a service, as a mobility as a service. You will go to point A to B. That's all. Imagine நீங்க திருவண்ணாமலையில உட்காடுறீங்க, காருக்கு சொல்றீங்க சென்னைக்கு என்ன கூட்டிட்டு போனேன். சென்னையில அது போய் உங்களை நிக்க வைக்குது நீங்க போகணுன்ற இடத்துல. And imagine this happens over a night, right? நீங்க தூங்கிட்டே போலாம், right? Without even have to bother about anything, right? So these are all the important aspects of this driving, right? So this also gives a picture that will it steal the job of driver? அப்படின்னா கார் டிரைவரோட வேலை எல்லாம் போயிடுமா? கார் மெக்கானிக்ஸ் எல்லாம் போயிடுவாங்களா? நான் மெக்கானிக் ஷாப் வச்சுட்டு இருக்கவங்களாம் போயிடுவாங்கன்னா, see, this is evolution. 100 years before, நம்மளுடைய எல்டர்ஸ் எல்லாரும் வந்து, நம்மளுடைய ஃபோர் ஃபாதர்ஸ் எல்லாரும் வந்து ஹார்ஸ் ரைடிங் பண்ணியிருப்பாங்க, குதிரை ஓட்டியிருப்பாங்க, மாட்டு வண்டி வச்சிருந்திருப்பாங்க, ரைட்? நமக்கு இப்ப எல்லாருக்கும், இங்க இருக்கிற எல்லாருக்கும் குதிரை ஓட்ட தெரியுமா? தெரியாது இல்லையா? ஆனா அந்த டைம்ல குதிரை ஓட்டுறது ஒரு நார்மலான ஒரு 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 ஆக்டிவிட்டி, ரைட்? அண்ட் தேர் வுட் ஹவ் பீன் இண்டஸ்ட்ரீஸ் லைக் ஹார்ஸ் ஷூ பண்ற இண்டஸ்ட்ரி இருந்திருக்கலாம், ஹாஸ்பிட்டல்ஸ் இருந்திருக்கலாம், இல்லைன்னா அந்த அந்த ஹார்ஸ் வேகன் செய்யற இண்டஸ்ட்ரி இருந்திருக்கலாம், ரிப்பேர் பண்ற இண்டஸ்ட்ரி இருந்திருக்கலாம். பட் ஆல் தீஸ் இண்டஸ்ட்ரி ஆர் எக்ஸ்டிங்க்ட், ரைட்? அதெல்லாம் இப்போ இல்லவே இல்லை, ரைட்? அதே மாதிரி தான் இந்த எவல்யூஷன் இருக்கும். அண்ட் வி ஹேவ் டு அடாப்ட் திஸ் எவல்யூஷன், ரைட்? ஸோ தட்ஸ் த பாயிண்ட் ஐ வாண்ட் டு மேக் ஹியர். Similarly, there is evolution in autonomous drones, right? The drones that can reach to far off location and do some task, right? Today we have in military, of course, the unmanned aerial vehicles, but this is more in the civilian airspace where you have a lot of options, right? For instance, there are applications where you can use autonomous drones for pest control in field, or to water plants in an agriculture, right? So on and so forth. And then there is also proposals for autonomous ships, right, in the far off seas. And there are also robotic surgeons, right? A lot of minute surgeries are performed by robotic hands, which are much efficient than a doctor doing this operation. Okay. With this, I'll go to the next slide. Okay, so important aspect, like I mentioned earlier, is autonomous driving, right? In order to know autonomous driving, it has to do navigation, right? So the robot பாத்தீங்கன்னா இப்போ ஒரு பாயிண்ட் ஏல இருந்து பாயிண்ட் பிக்கு போனோம், அது எப்படி போனோம்னு அது தெரிஞ்சுக்கணும். அதுக்கு வந்து 3 கேள்வி அது கேட்கணும். நான் இப்போ எங்க இருக்கிறேன், ஓகே, நான் எங்க போனோம், அதுக்கு எப்படி போனோம், இந்த 3 கேள்வி தான் நம்ம கேட்கணும். அந்த 3 கேள்வி அதுக்கான பதில் தான் வந்து ஸ்லாம் வந்து ஒன் அமாங் த பதில் தான் வந்து ஸ்லாம் என்ன பண்ணும்னா, it's called a simultaneous localization and mapping, meaning it will actually tell where the map is at the moment relative to the items present in that environment. So basically it will do a scanning, right? It can do a LiDAR based scanning so that it can detect objects or obstacles, or it can make a camera based depth scanning to have a depth image, and then it can classify object, and then it can analyze the depth and the pose of the robot, and using it makes a map. That means it will make an offline map on how the environment look like, and then it does so-called path planning, and based on the path planning it will find, okay, நான் பாயிண்ட் ஏல இருந்து பாயிண்ட் பிக்கு போனோம்னா இதுதான் ஈஸியான வழி, பாயிண்ட் பில இருந்து சிக்கு போனோம், இல்ல நான் பாயிண்ட் பிக்கு பதில் பாயிண்ட் சிக்கு போனோம்னா அதுக்கு எப்படி போனோம், அந்த மாதிரி all these are done based on these inputs that the robot does, right, or robot makes in this map. But how does this again does is similar, back to basics, the sense, think, act paradigm, right? It will sense there is an obstacle, think what should I do, should I go front, left, right, and then it will act, okay, I'm moving, what should be my speed, na ipo or obstacle paathuta, what should I do, stop, all this has to be like an recursive paradigm, okay? Or practical example, right? This is a simulator, right? This is a simulation environment. It's called Gazebo. So I will actually provide links to it, and I strongly encourage you all, if you have interest in learning robotics, So these are all the tools you have to learn. This is quite easy. You can learn whatever I'm telling you in about days or weeks. It's quite easy, and you can do a lot of stuff, right? Like here, in the first picture, you can see that here is a robot, and it has two sensors basically, a camera and a laser scanner, a lidar, and then it can see that obstacles, right? The obstacles are marked with this boundary, right? Here is a wall, so it has this boundary lines, and then it is detecting the items in the front, in the right side, and then it's keep on exploring. So when the robot goes from this point to this point, what you see in the picture number 2, it has already covered major area here, right? Then followed by the third picture. In this position, it has much more localization, and by end of the fourth picture, it can see that it has already mapped the complete area. So now the map knows its locality, and it knows exactly what are all the obstacles, where are all the walls. If you can imagine this, இது ஒரு வீடா நீங்க imagine பண்ணீங்கன்னா, the robot, இது ஒரு cleaning robot-ஆ நீங்க நினைச்சிட்டீங்கன்னா, இப்போ உங்களுக்கு தெரியும் ரோபோட்டுக்கு எங்க இருக்கு, இந்த ரூம் எங்க இருக்கு, வால் எங்க இருக்கு, படிக்கட்டு எங்க இருக்கு, நாங்க போக கூடாது ஏன்னா கீழே விழுந்துரும், right? All these things can be used for its navigation, right? So this is a simple example of how you do the slam, right, in a simulation environment. I have something interesting to show you, right? This is the robot. It's called Oblix robot. This is done by University of Freiburg in Germany. இது ஒரு research robot. அது என்ன பண்ணிருக்காங்கன்னா, these robots is designed in a way that it can go in urban regions for providing services. When I say urban region, it has to be like densely populated region, right? It can be ஒரு மால்லையோ இல்ல ஒரு திருவிழாலையோ இல்ல it can be in a crowded place. It has to navigate itself and go to a point. So and this is a research project. I just want to give you a small video of it. Do you guys see the video? Can I have an S?
Yes.
Yeah. Okay. Yeah. So as you can, yeah. Thank you. Thanks for the confirmation. As you can see here, the robot has a camera, a long-range camera, and also the lidars. The lidar mapping is what you are seeing to your left. So all these things are the point clouds that is helping you identify object and obstacles. And this is something they have superimposed on a map to tell where exactly the robot is going, followed by the camera image itself. So I'll let you guys have a short discussion about it. So what you see in the back is 4 people following the robot. Okay, those students, அவங்க அந்த robot follow பண்ணிட்டு வராங்க. So you can even say that which direction அவங்க வராங்க அதெல்லாம் அதால detect பண்ண முடியும். And imagine, the path planning is done by the robot itself. So there is nobody is telling to go to left or right or whatever. So இங்க பாத்தீங்கன்னா அங்க red signal இருக்கு pedestrianக்கு. So it will wait until there is green, and then it'll proceed. I will scroll a little bit up where there are more people. This is really, wait, yeah. It knows how to avoid a cyclist and stay to, on the pedestrian lane layer try பண்ணுது, not to go into bicycle lane. And this is the city center actually, so it can actually navigate in such a tight space, where there is constant movement of people, and then it can still able to do it. Of course, there is some manual interruption every now and then, but at least to what you're seeing, this research is really enormous for the times. Okay, I think that's enough for the moment. So what are all the other robots we have, right? We have, for example, logistics. There are autonomous navigating robots that's used, for instance, in the food delivery business. So it delivers food, and also it's being actively used in grocery delivery. So what you are seeing here is from a supermarket in the United Kingdom, in London, basically, and where they are already able to provide groceries for elderly people, who are either quarantined or they are not allowed to travel because of COVID pandemic, right? So what are all the other applications, right? It can also used in case of last mile delivery, right? What is a last mile delivery is you have a big truck, an Amazon truck or whatever, or an UPS truck, which is bringing parcels or whatever, but it cannot reach your house or it cannot reach your apartment block, right? உங்க வீடு ஒரு 100 apartments இருக்கிற ஒரு blockல அவரால் எடுத்துட்டு வர முடியாது அந்த ட்ரக்கை. So you can put your things in one of these small robots, and the robots could deliver it to your place, right? So how cool is that? Then there are these AMR robots for industry 4.0. Okay, little bit. I know there are mechanic students in this forum. I'll tell a little bit about Industry 4.0. Industry 4.0 itself is a big topic on its own, so I cannot cover it fully. I have to do a dedicated session for it. But in a nutshell, what is Industry 4.0 is, normally in an industry, if you are making one product, let's say you are making a car. Let's imagine நாம வந்து ஒரு மாருதி கம்பெனின்னு வச்சுக்கலாம். இப்போ மாருதி கம்பெனில உங்களுக்கு வந்து மாருதி ஆல்டோன்னு ஒரு மாடல் வரும். I don't know, அது ஸ்டில் இருக்கான்னு எனக்கு தெரியல. There is Alto, and there is I don't know, like for example Maruti Ertigaன்னு ஒரு மாடல் இருக்கு, right? So for different types of model, there will be two different production line, right? What you have, although இப்பெல்லாம் வந்து common chassisல build பண்ணாலும், there will be lot of components and lot of product variants that you cannot do the same product or two different product in the same production line. So what companies normally tend to do is they normally have two different lines, and then of course they will still employ robotic arm for soldering and stuff like that, but still it will be a two different line, right? But what happens in case of Industry 4.0 is you can have a customizable line, meaning you can have one common line that does multiple product variants with multiple customization, right? For example, you can make product like Alto in this model, and you have Ertiga with a high-end model or with a personalized model. Maybe அந்த சீட்ல வந்து உங்க பேரை வந்து லோகோவா போடணும் அப்படின்னு நீங்க ஒரு வேரியன்ட் நீங்க ஆர்டர் பண்ணிருந்தீங்கன்னா, அந்த மாதிரி கஸ்டமைசேஷன்லாம் Industry 4.0ல பண்ண முடியும். எப்படி பண்ண முடியும்னு சொன்னீங்கன்னா, all from an IoT standpoint, right? From an Internet of Things standpoint, every component, every movable part, every entity in an Industry 4.0 world has an IP, as a physical address, has a MAC address. That means everything will talk to its network, right? So that is how you build an Industry 4.0, right? So probably I cannot go even depth beyond this, right? But this is the future, right? If you are in mechanical industry and if you want to, do something wonderful, please explore Industry 4.0, right? So that's what I can recommend you. And to your right, you can see the assembled robots. Like I said, if you are working in a completely human-based production line with fewer use of robots, customization, highly customizable products will be very expensive, right? But with Industry 4.0, you can really produce highly customizable product in a much lower cost, and also the efficiency seems to be much better in comparison with how a human would do. Companies like Audi and BMW here in Germany already has this 4.0 being established, and I am sure industries in India is also following this path. Okay, also followed by the supplier robots, which is basically robot which can deliver parts and things autonomously within the shop floor, right? So it can auto summon the product, or if it has a traffic, for example, it cannot navigate fast, it can ask other robots to it can relay the message so that other robots could go to the part of the factory where it needs immediate attention, etc. So this is the major difference between an AGV, which we have spoken earlier, right? In an AGV, normally you have a marked area or I don't know, a line or a path or a track where they say the robot has to operate only within this track, but we don't have this kind of limitation in case of AMR, right? So it can work freely in an environment where it can share the workplace with the human and also provide very high safety standards, right? Some use in agriculture. What you're seeing here is a robot that can actually water the plants, or even do pest control, put fertilizers, etc. And there are also robots for planting, harvesting, weed control, all these things, right? And in the area of safety, there are robots which are meant for firefighting. This can be autonomously driven, or it can be remotely operated as well from a firefighter in the back, so that this gives much more access to the area where firefighters cannot reach easily, or this gives more safety for the firefighters themselves, so that they don't have to encounter directly in the line of fire, but rather let the robot do its job. And also there are robots for search and rescue operations in terms of natural calamities, right? For instance, autonomous robots autonomous boats or autonomous drones that can do aerial surveying, remote sensing, etc. Aerial vehicles that can remote sense enemy targets, or even the robots that can do scanning, so that there are no excuse me, landmines in a war zone, right? Excuse me. All right, so there are even more robots, than what we are seeing here. There are robots used in mining industry that can do mining, and several other industries. The scope and the usage is enormous, and sky's the limit for this industry. And this is budding, meaning this is evolving, and so there can be a lot of new applications that could be developed eventually. Okay, a little bit about a small demo I want to show you guys, which I did with one of these robots. What you are seeing to your right is an educational robot. It's called as Turtlebot 3. This robot is really a low-cost robot, which is used primarily for education and also for learning robotics. And it has inbuilt LiDAR. What you're seeing on top is the LiDAR sensor, and then there is a camera which can be used for object detection and object classification, etc., and do computer vision with this. And in this example, what I have actually I did it as part of one of the a demo project I have did for learning robotic itself from University of South Carolina in the US. What the robot normally does, it follows a line normally, and the line is identified by a color. Basically, the camera tracks this image, and then it is matching the color. Once it matches the color, it will follow the line, and then it will detect any obstacle on the way. It will avoid the obstacles, and then it will navigate to the goal position. And when it is navigating to the corners, it will also control the speed. So maybe enough talking. I can show you this demo to you guys. You guys see the video? Can I have an yes?
Yes, sir. Yes, sir. See the yes, sir. Yes.
Yeah. All right. So as you can see here, the robot just follows the line and then it's navigating. Okay. So the direction is controlled, like I said, by the differential acceleration between these two wheels, right? So one wheel goes slow, another one goes fast, and then it turns the direction. So this is from the view of the person. Let's have a view from the robot standpoint. Let's see how the robot looks at this. Here you go. So I'll pause there for a moment and then I will explain you what you're seeing in the robot. Okay, what you're doing now is you have the camera, right, which is basically capturing the image, and then in the camera I'm picking a point, right? I'm in this point I'm telling, okay, what you are seeing in the red dot is my point of reference. In this point of reference, I'm matching a color. In this matching, meaning I'm telling the machine or I'm telling the robot that it has to look for this color. And once the robot knows that it has to look for it color, it will keep on, searching for this color, and then it'll learn to know this color. And for the sake of image processing, I will convert this into a line mask so that it is easy and it is much less CPU intense, because if you are doing this color masking from a color image itself, the number of CPU cycles required is really enormous. So in a real world, I would just crop this image and then I'm telling, don't look at here, just look at this point of this video, and then look for this color, and then navigate, and move your robot. And if the line goes to your left, you go to your left, and right, whatever, that's what you're seeing here. What you're seeing is the command that the robot does. And what you're seeing to your left is the object detection algorithm that the camera is running. Okay, so all the simulation environment is done with the robot, along with the different tools like Gazebo, etc. So I'll let it run now. I hope it makes sense what I was trying to show you. Good. All right, so I think that is all I have from a robotic standpoint. But then I have something to tell, right? Maybe some words on what you can take as a key takeaway, right? I have few for the teaching community and also a few items for the students out here. I'm really glad that we had over 100 folks able to join today this morning. I'm very delighted and happy. So first, I will start with a few words to the teaching community. If you want to facilitate robotic, in your institution, you can consider investing in one of these hardwares, right? This hardware can be a Turtlebot robot, which costs about 35,000 rupees, or even a BBC Micro bit. It starts as low as 2,000, or Raspberry Pi, right? All these are all microcomputers that can be used. Can we mute, please? Or are there any questions? Okay, all right. Yeah, so yeah, try investing in hardware, right? It can be one hardware that can be shared across the department or whatever, right? This is a strategy that you can build. And what I want to also recommend is go beyond syllabus if possible, right? Syllabus can be a bare minimum for a student that has to clear exams and get a degree. But if you have a student that can go beyond, right? Encourage a student, right? They need not be limited by the syllabus. They can do more work. They can push themselves to learn a lot of new stuff that can be really beyond syllabus, right? Beyond learning and getting the marks, right? So try to have always this attitude. And also encourage your students, if possible, to do some micro certification, right, as a coursework, right? Instead of asking them to write a assignment, maybe they can do a small course, right, in Coursera or Udemy, or even there are thousands of MIT videos in YouTube, right? So they can listen to a lecture, which can be like 4 hours or a 5 hours lecture, or a coursework in Coursera, which gives you a micro certification when you're reading it like 5 or 6 hours, right? So this can be something that you can consider giving to your students. And like this event, right? Always try to have this bridge with industry, right? Always please be a bridge. I guess you guys are doing it anyway, so I would still encourage you to do it. And to the student community, a few words. If you want to get to know robotics, please get your hands dirty, meaning try to learn how to work. So Turtlebot 3 could be a very good starting point. Then try to learn ROS, which is basically robot operating system, which has all the frameworks, so you don't have to reinvent the wheel. Much of the things what I have explained is already available, and you can already do such simulation in about less than a week, I would say. And have one language as your strong language, right, in programming. Let it be Python or C++, but try to learn and be a very strong player in these languages, right? You don't have to learn all the new languages, etc. But when you learn one language, try to really master that language. Try to go in depth and breadth of the language, and then try to master it. And for the folks, at least computer science and other folks, please have Linux as your OS. Try to learn Linux, which really plays off. You can do so many number of things that you can do with Linux. And also, please familiarize yourself with GitHub. GitHub is basically a repository for code, where you have softwares you can collaborate and then you can use. So please try to familiarize and learn. I guess most of us have WhatsApp and Facebook and other social media. In similar lines, I would encourage you to all have these professional social media, which is this LinkedIn, which basically has people in the industry, and it can able to connect with other people in the industry. So if you want to become or get inspired with somebody, you can look into them in the profile, and then you can see how they reach to that level, what they did in their life to reach that. Maybe you can take it as your inspiration to reach that, right? And last but not least, have a mindset, right? நான் இந்த கோர்ஸ் முடிச்ச உடனே எனக்கு வேலை கிடைக்கும் அப்படின்ற ஒரு எண்ணத்தை மாத்தி, என்னாலே ஒரு 4 பேருக்கு வேலை கொடுக்க முடியும் அப்படின்ற ஒரு ஆண்டர்பிரினர்ஷிப் ஆட்டிடியூட் உங்ககிட்ட வளர்த்துக்கிட்டீங்கன்னா இன்னும் நீங்க கிரேட்டர் ஹைட்ஸ்க்கு ரீச் ஆவீங்கன்றது என்னுடைய ஒப்பீனியன். ஸோ with this, I like to thank the Department of HIS, Dr. Ravichandran, and thank Principal Dr. Ravichandran, and also the management, Arunai Engineering College. I'm really delighted this morning, right, to talk to you all, folks. Normally Friday we say here, thank God it is Friday, right, because we are looking for a weekend. But I have to say what a day it is, because I have to talk to my juniors and my alma mater. So it cannot be any better. So that's what I want to say. So with this, maybe we can open for any Q&A. I don't know how long we have. Can we take questions?
Thank you very much, Balaji, for salad through mobile robots, how it prepares food through COVID situations. Like a number of innovative ideas they are having. I hope definitely they will contact you in future to enlighten their bright future also. Thank you, Balaji, for your valuable time with us after a long time. Plan to visit the campus also. We have probably MOU with Intel Inc. To incorporate that learning environment at Arunai campus soon. We will keep in touch with the higher level people.